The universe is a place of unimaginable violence and beauty, a stage where cataclysmic events unfold on scales so vast they defy human comprehension. Yet amid this cosmic chaos, there are stories of survival so extraordinary they border on the impossible. Picture a galaxy hurtling toward a supermassive black hole, its fate seemingly sealed, or a cluster of stars caught in the crossfire of colliding cosmic titans. By all known laws of physics, these galaxies should have been torn apart, reduced to cosmic dust, but somehow, against all odds, they endured. These aren't just tales of near misses, they're cosmic miracles that challenge everything we think we know about the fabric of reality. And today, we're diving deep into 20 of these mind-bending events, each one a testament to the universe's mysterious resilience. What does it take for a galaxy to cheat destruction? Is it sheer luck, or are there hidden forces at work, laws of physics we've yet to uncover? From gravitational anomalies that bend space-time to unexplained energy surges that defy logic, these cosmic survivors hold secrets that could rewrite our understanding of the cosmos. Imagine a black hole with the power to swallow entire stars, yet its host galaxy remains untouched, or a collision between two galaxies so violent it should have sparked a chain reaction of annihilation, but instead, they merged into something even more magnificent. These aren't just hypothetical scenarios, they're real events documented by astronomers that leave even the brightest minds in astrophysics grasping for answers. This journey isn't just about listing cosmic near disasters, it's about unraveling the mysteries that keep galaxies alive when all odds say they shouldn't be. It's about peering into the heart of the universe's most violent phenomena and discovering the delicate balance between destruction and survival. By the time we're done, you'll see the cosmos in a whole new light, not just as a cold, empty void, but as a place where the impossible happens every day. So settle in, because what you're about to witness will stretch your imagination, challenge your assumptions, and maybe even make you wonder, if galaxies can survive against these impossible odds, what else might the universe be hiding? The first cosmic event on our list sounds like something straight out of science fiction, a supermassive black hole, hurled from its home galaxy like a cosmic cannonball, streaking across the void on a direct path toward destruction. Astronomers watched in disbelief as this gravitational monster, weighing billions of times the mass of our Sun, barreled toward a stunning spiral galaxy. The math was clear. The impact should have torn the galaxy apart, scattering its stars into oblivion. But then, the impossible happened. At the last possible moment, the black hole swerved, as if nudged by some unseen hand. Instead of catastrophe, all that remained was a ghostly ripple of distorted starlight, a cosmic near miss that left scientists stunned. What could have steered a force of nature so powerful, not even light can escape its grip? Some theories point to dark matter, the invisible scaffolding of the universe, whose gravitational pull might have yanked the black hole off course. Others speculate about hidden dimensions or exotic physics we don't yet understand. But one thing's certain, this wasn't just luck. The precision of that last-minute deflection suggests forces at work beyond our current models, almost as if the universe itself intervened to spare that galaxy. And here's the real mystery. If a black hole moving at those speeds could be redirected so effortlessly, what else in the cosmos might be under the influence of these unseen cosmic puppeteers? This event doesn't just challenge our understanding of black holes, it rewrites the rules of cosmic survival. Galaxies aren't just passive structures drifting through space, they exist in a delicate dance with forces we're only beginning to detect. That spiral galaxy should have been a goner, yet it emerged unscathed, its stars still shining, its spiral arms intact. It's a humbling reminder that for all our telescopes and equations, the universe still holds cards it hasn't shown us. And if a black hole can miss its mark, what other cosmic bullets might be dodged out there, silently bending the odds in favor of survival? The Andromeda galaxy witnessed something that defied every textbook on stellar explosions. Scientists watched as a massive star, poised to erupt in one of the most violent events in the universe, a supernova, suddenly faltered. Instead of lighting up the cosmos with a brilliant, destructive flash, it simply faded like a firework doused with water before ignition. This star collapsed inward with barely a whimper. The energy that should have shredded nearby star systems vanished, leaving astronomers scratching their heads. How could a star cheat death so spectacularly, avoiding the very fate written into its DNA? Supernovas aren't just random explosions, they're the final, desperate breaths of dying stars, cosmic detonations so powerful they outshine entire galaxies. The shockwaves forge heavy elements, scatter stardust across the universe, and sometimes even trigger the birth of new stars. But this star in Andromeda broke the mold. One leading theory suggests it might have undergone what's called a failed supernova, where the core collapses directly into a black hole without the usual fireworks. Think of it like a building imploding silently instead of exploding. Gravity wins without a fight, swallowing the star's energy before it can erupt outward. But here's where it gets even weirder. Some researchers argue this wasn't just a failed supernova, it might have been something entirely new. Imagine a star so massive, so unstable, that its own gravity acted like a cosmic failsafe, snuffing out the explosion before it could begin. Or perhaps exotic particles unknown to physics siphoned away the star's energy at the last second. Whatever happened, the implications are staggering. If stars can die quietly, how many others have slipped away unnoticed? And what does that mean for our models of how galaxies evolve? This quiet collapse challenges more than just our understanding of stellar deaths. It hints at hidden mechanisms governing the universe's most violent events. For every supernova we see lighting up the night sky, there could be dozens of these silent vanishings, rewriting the rules of cosmic destruction. Andromeda's fizzling star isn't just a curiosity. It's a clue that the universe still holds mysteries we haven't even thought to question. If stars can defy their own explosive destinies, what other cosmic rules might be waiting to be broken? Galactic collisions should be the ultimate cosmic train wrecks, violent, destructive events where stars are flung into the void and entire solar systems torn apart. So when astronomers spotted two massive galaxies on a collision course, they braced for catastrophe. These weren't just any galaxies. Each contained hundreds of billions of stars, their combined gravity capable of bending space itself. The math predicted chaos, a fiery ballet of shattered spiral arms, rogue black holes, and stars ejected into the darkness. But instead of destruction, something extraordinary happened. The galaxies didn't tear each other apart, they danced. Like two vast whirlpools merging into one, their spiral arms intertwined gracefully, as if guided by some unseen choreographer. Stars slipped past each other, their paths bending but never breaking. Even the supermassive black holes at their centers, which should have sent shockwaves through the merging galaxies, settled into a slow, steady orbit. It was as if the universe had hit the mute button on what should have been a deafening cosmic crash, and that's when astronomers realized this wasn't just luck. Something was holding these galaxies together, something invisible. The secret might lie in the dark matter halos surrounding each galaxy. Think of dark matter as cosmic glue, invisible, mysterious, but holding everything together with its gravitational pull. As the galaxies collided, their dark matter likely formed a vast, stabilizing scaffold, absorbing the shock and preventing chaos. Picture two crowds of people merging in a stadium, but with an invisible net keeping everyone from trampling each other. That's dark matter's role in galactic collisions, a silent guardian against the universe's worst tantrums. But here's what really bends the mind. This event suggests galaxies might be far more resilient than we ever imagined. If dark matter can shepherd stars through such a violent merger, what other cosmic disasters might it soften? Could entire galaxy clusters survive collisions we once thought were apocalyptic? This single event has forced scientists to rewrite the rules of galactic survival, proving that even in the universe's most violent moments, there's an invisible order, a delicate balance between chaos and harmony we're only beginning to understand. And that raises an even bigger question. If dark matter can stabilize something as catastrophic as two galaxies colliding, what else is it doing out there? Is it quietly orchestrating other cosmic near misses we haven't noticed yet? This merger wasn't just a fluke, it was a glimpse into the universe's hidden rulebook, where destruction and creation are two sides of the same coin. The next time you look up at the night sky, remember, those distant galaxies might be playing by rules we've only just started to decode. Quasars are the universe's ultimate powerhouses, lighthouses of raw energy so intense they can outshine entire galaxies. So when one of these cosmic behemoths, blazing with the light of 1 trillion suns, suddenly winked out of existence, astronomers were left staring at empty space where there should have been devastation. This wasn't just a quasar dimming or fading slowly. It vanished in what amounts to a cosmic blink of an eye, and the strangest part, its host galaxy remained perfectly intact, as if the quasar had never existed at all. Normally, a quasar's disappearance should leave behind a trail of destruction. These objects are powered by supermassive black holes feeding on surrounding matter, unleashing enough energy to sterilize entire star systems. The radiation alone should have scoured nearby planets of any atmosphere, and the gravitational upheaval would have sent stars careening into chaos. Yet when scientists trained their telescopes on this galaxy, they found nothing, no scorched planets, no displaced stars, just eerie, undisturbed silence. It was like a hurricane vanishing mid-storm, leaving calm seas behind. So what could explain this impossible shutdown? One theory suggests the quasar's black hole might have abruptly stopped feeding. Picture a faucet turned off at the source. No more matter falling in means no more light blazing out. But even that doesn't fully solve the mystery, because the energy already released should have left lasting scars. Another idea, something might have intercepted that energy before it reached the galaxy. Imagine a cosmic sponge soaking up the quasar's fury before it could do damage. Some researchers even speculate about exotic physics, dimensional shifts, or quantum barriers that effectively unplug the quasar instantaneously. But here's the real head-scratcher. If quasars can disappear without consequences, how many others have done the same? Could this be a hidden survival mechanism for galaxies? A way to reset their central engines before catastrophe strikes? This event doesn't just challenge our understanding of quasars, it hints at gaps in our knowledge of how galaxies regulate their most violent elements. For all their power, quasars might be more fleeting, more fragile than we ever imagined. And that raises an even bigger question. In a universe full of cosmic time bombs, how many other ticking clocks have quietly stopped without us noticing? The implications stretch far beyond a single vanished quasar. If these cosmic monsters can flicker out harmlessly, entire models of galactic evolution might need rethinking. Perhaps galaxies have unseen safeguards, emergency shutoffs we don't yet comprehend. Or maybe the universe has a way of balancing its books, erasing debts of energy before they come due. One thing's certain, this wasn't just a fluke. It was a message written in the sudden silence of a trillion suns, telling us there's still so much we don't understand about the forces shaping the cosmos. And if a quasar can disappear without a trace, what other cosmic certainties might be waiting to vanish before our eyes? Gamma-ray bursts are the universe's ultimate death rays, cosmic lightning bolts so powerful they can outshine entire galaxies in seconds. These explosions, born from collapsing stars or colliding neutron stars, unleash enough energy to vaporize planets light years away. So when astronomers detected one of these bursts erupting dangerously close to a small, unassuming galaxy, they expected the worst. The math was brutal. At that distance, the gamma-ray jet should have scoured the galaxy clean, stripping away atmospheres, frying any potential life, and leaving behind a radioactive wasteland. But against all odds, the galaxy survived. Not just barely, it emerged completely untouched, as if the burst had never happened. What could possibly shield a galaxy from an explosion capable of sterilizing half the universe? The answer might lie in something we can't even see, a colossal magnetic force field. Imagine a vast, invisible web woven around the galaxy, its strands made of magnetic energy so dense they deflect even the deadliest radiation. This wasn't just a random cosmic fluke. The galaxy's magnetic shield acted like a celestial umbrella, bending the gamma rays away before they could do damage. Scientists studying the event likened it to a ship weathering a tsunami because of an unseen barrier just beneath the surface. But here's the twist. Magnetic fields strong enough to block a gamma-ray burst shouldn't exist naturally. They'd require energy sources far beyond what a small galaxy could muster. So how did this one pull it off? Some researchers speculate the galaxy might be sitting on a hidden wellspring of power, perhaps a network of rapidly spinning neutron stars, their combined magnetic fields amplifying into a protective bubble. Others wonder if dark matter played a role, its gravitational influence shaping the magnetic shield like an invisible hand. Whatever the cause, this event proves that galaxies might have defenses we never knew existed. The implications are staggering. If one galaxy can armor itself against the universe's deadliest explosions, how many others might be doing the same? Could magnetic shields explain why some galaxies thrive in regions littered with gamma-ray bursts while others perish? This tiny, unremarkable galaxy didn't just survive, it revealed a cosmic loophole, a way to cheat a death sentence written in gamma rays. And that raises an even bigger question. In a universe filled with invisible dangers, what other survival tricks are galaxies hiding? What makes this even more mind-bending is the timing. Gamma-ray bursts are fleeting, most last mere seconds. For the galaxy's shield to activate instantly, it would need some kind of early warning system, a way to sense the incoming danger and react faster than physics should allow. It's almost as if the galaxy itself knew what was coming. Could magnetic fields be more than just cosmic armor? Could they be part of a larger, almost lifelike system of galactic self-preservation? This event doesn't just challenge our understanding of gamma-ray bursts, it forces us to rethink how delicate structures like galaxies endure in a violent universe. We used to think of them as passive victims of cosmic chaos, but now we're seeing hints of something else. Galaxies as active survivors, equipped with defenses we're only beginning to detect. And if magnetic shields can turn the universe's most lethal explosions into harmless light shows, what other miracles might be hiding in plain sight, waiting for us to notice? Neutron star mergers are supposed to be the universe's ultimate fireworks. Cosmic car crashes so violent, they shake the fabric of space-time itself. These ultra-dense stellar corpses, each packing a sun's worth of mass into a city-sized sphere, should unleash chaos when they collide. Blinding gamma-ray bursts, rippling gravitational waves, and shockwaves powerful enough to forge gold in their wake. But when astronomers witnessed two neutron stars spiraling toward each other in a distant galaxy, the universe threw them a curveball. Instead of a cataclysmic explosion, the stars merged in eerie silence. No brilliant flash, no space-time ripples, just nothing. It was like watching a bomb detonate without the bang, a cosmic magic trick that left scientists scrambling for answers. How could something so violent happen so quietly? The leading theory involves an exotic form of matter never before observed. Neutron stars are already so dense, their cores might as well be made of sci-fi material. But if the pressures during this merger crossed some unknown threshold, the stars could have collapsed into something even stranger, a quark star, where matter breaks down into its most fundamental components. Picture a snowball melting into water, but on a cosmic scale. Instead of rebounding into a fiery explosion, these neutron stars might have dissolved into a smooth, ultra-dense soup, their energy vanishing into the quantum foam of the universe. But here's where it gets even weirder. Some researchers argue this event might hint at a hidden law of physics, a kind of cosmic failsafe that kicks in during extreme collisions. Think of it like a pressure valve on a boiler. When things get too intense, the universe steps in to prevent total chaos. If true, it would mean neutron star mergers aren't just random explosions but carefully regulated events, governed by rules we've yet to uncover. And that raises a tantalizing question. If some mergers are silenced, how many others have we missed? Could the universe be full of these ghostly collisions, rewriting the story of how heavy elements like gold and platinum are made? The implications stretch far beyond a single silent merger. If neutron stars can collide without fireworks, entire models of cosmic chemistry might need revisiting. These events are supposed to be the universe's primary forges for heavy elements, the cosmic factories where the gold in your jewelry was born. But if some mergers skip the explosion, where does that leave our understanding of how these elements spread? This event doesn't just challenge astrophysics. It rattles the very foundation of how we think matter is created and distributed across the cosmos. What's truly humbling is how much we still don't know. For decades, neutron star mergers were textbook examples of predictable chaos. Now, we're staring at proof that the universe has playbooks we haven't even glimpsed. This silent merger isn't just an oddity, it's a beacon, illuminating the gaps in our knowledge. And if neutron stars can defy expectations so spectacularly, what other cosmic rules might be waiting to be rewritten? The next time you look up at the night sky, remember, out there in the darkness, the universe is still keeping secrets, and sometimes the most profound discoveries come not from the explosions but from the silence. Cosmic rays are the universe's silent assassins, subatomic bullets traveling near light speed, capable of shredding through planets and sterilizing entire star systems. So when a galaxy found itself in the crosshairs of one of the most intense cosmic ray storms ever recorded, scientists braced for devastation. These weren't just stray particles. This was a concentrated barrage, a cosmic machine gun firing high-energy protons, an atomic nuclei with enough force to strip away atmospheres and mutate DNA. The galaxy should have been left a barren wasteland, its stars surrounded by dead planets. But when astronomers looked closer, they found something impossible. The galaxy was thriving, untouched, as if shielded by an invisible force field. The culprit, a mysterious dark matter anomaly, a vast, swirling halo around the galaxy that acted like a cosmic umbrella. Dark matter. The invisible stuff that makes up most of the universe's mass usually just provides gravitational scaffolding, holding galaxies together. But this time, it did something extraordinary. It absorbed or deflected the cosmic rays before they could reach the galaxy's stars. Picture a bulletproof vest made of shadow, catching every lethal particle mid-flight. Even more baffling, the dark matter didn't just block the rays, it seemed to scatter them, redirecting their energy harmlessly into space. This wasn't just a lucky break, it was a cosmic revelation. Dark matter might be far more complex than we thought. For decades, we assumed it was passive, a silent partner in the universe's grand design. But this galaxy's survival suggests dark matter could interact with other forces in ways we've never imagined. Some theories propose exotic dark matter particles with electromagnetic properties, or even an unknown fifth force of nature acting between them. Others wonder if dark matter can form dense, structured barriers, like invisible reefs breaking the tide of cosmic radiation. The implications are staggering. If dark matter can protect galaxies from cosmic rays, could it also shield them from other threats, gamma-ray bursts, supernova shockwaves, or even black hole jets? And here's the real kicker. If dark matter isn't just a gravitational glue but an active cosmic defense system, how many other galaxies might be wearing this invisible armor without us knowing? This anomaly forces us to rethink everything. Dark matter might not just shape the universe, it could be silently safeguarding it, a hidden guardian against the cosmos's deadliest forces. And that raises a humbling question. In a universe where even empty space holds secrets, what other invisible protections might be woven into the fabric of reality? This galaxy didn't just survive a cosmic ray storm. It revealed a universe far stranger and far more mysterious than we ever dared to dream. Hypervelocity stars are the universe's runaway bullets, stellar projectiles ejected from their galaxies at speeds topping millions of miles per hour, never meant to return. So when astronomers tracked one of these stars hurtling toward intergalactic exile, its fate seemed sealed. This wasn't just a leisurely drift into the void. It was a full-blown cosmic slingshot, propelled by the gravitational kick of a supermassive black hole. The math was clear. At that velocity, the star should have escaped its galaxy's pull forever, condemned to wander the darkness between galaxies. But then, the impossible happened. Against all odds, the star slowed, not gradually as if fighting gravity, but abruptly as if something yanked it backward. And then, defying every model of celestial motion, it curved back toward home. What could possibly halt a star moving that fast? The answer might lie in the invisible scaffolding of the universe itself. Dark matter, the mysterious substance that outweighs visible matter 5-to-1, could have formed an unseen gravitational net, stretching far beyond the galaxy's visible edges. Picture a rubber band snapping back after being stretched too far. Except in this case, the rubber band is made of shadowy, unknown particles, and the force pulling the star home is stronger than anything we've measured. Some theorists even speculate about rogue black holes lurking in intergalactic space, their immense gravity acting like cosmic fishing hooks, reeling the star back from oblivion. But here's where it gets even stranger. The star didn't just slow down, it accelerated on its return trip, as if being actively dragged. That's not how gravity alone should work. Normally, an object escaping a gravitational pull loses speed, not gains it. This suggests something else was at play, perhaps a dense knot of dark matter, or even a flaw in our understanding of how gravity operates over vast distances. Could there be regions of space where the rules bend, where gravity strengthens instead of weakens? This single star's U-turn might be pointing us toward one of physics' greatest unsolved mysteries. The implications ripple far beyond one rogue star. If galaxies are surrounded by invisible gravitational anchors, entire models of cosmic evolution might need revising. Stars, it seems, aren't just floating freely in space. They're tethered to forces we can't yet see. And if hypervelocity stars can be summoned back, what else might these hidden forces be controlling? Could entire galaxies be held in place by similar cosmic puppet strings? This event blurs the line between chaos and order, suggesting the universe has a way of reigning in its runaways, a hidden hand guiding what we once thought was random. What's truly humbling is how much we still don't understand. For centuries, we've mapped the heavens assuming gravity follows neat, predictable rules. But this star's return throws a wrench into that simplicity, hinting at a cosmos far more interconnected and far weirder than we imagined. The next time you gaze at the night sky, remember, out there, in the void, the universe might be playing a game of cosmic tug-of-war with rules we're only beginning to glimpse. And if a star can defy the odds so spectacularly, what other secrets might the darkness be hiding? Supermassive black holes are the ticking time bombs at the heart of galaxies, sleeping giants capable of erupting with enough energy to reshape entire cosmic landscapes. So when astronomers detected unmistakable tremors from one such black hole, a telltale buildup of radiation and swirling matter signaling an impending explosion, they prepared to witness a cataclysm of epic proportions. The signs were all there. The black hole's accretion disk glowed white-hot, its gravitational pull distorting space-time like a twisted rubber sheet. Everything pointed to a violent outburst, a quasar-like eruption that would flood the galaxy with lethal radiation. But then nothing happened. The tremors ceased. The disk cooled, the black hole settled back into eerie calm, as if some unseen hand had flipped a cosmic off switch. This wasn't just a delayed explosion, it was a full-blown suppression, a defiance of everything we know about black hole behavior. Normally, once the process starts, there's no stopping it. Matter spiraling into a black hole's maw generates unimaginable friction, like water circling a drain at near light speed. That energy has to go somewhere, usually erupting in jets of plasma or bursts of X-rays. But this black hole somehow absorbed the energy without releasing it, a feat akin to a volcano sucking its own lava back underground. What could possibly silence a supermassive black hole on the brink of eruption? One theory points to magnetic fields so powerful they act like cosmic rains, channeling the black hole's energy back inward. Picture a whirlpool with an invisible mesh stretched across its surface, preventing water from splashing out. Another idea suggests the black hole might have hit a stability threshold, a sweet spot where incoming matter is perfectly balanced against its own gravity, creating a feedback loop that prevents outbursts. It's like a pressure cooker with a self-adjusting valve, regulating itself before the steam can blow. But the most tantalizing possibility, black holes might possess a form of self-awareness. Not consciousness as we understand it, but an intrinsic ability to sense and regulate their own activity. Think of it as a cosmic immune response. When a black hole's energy output threatens to destabilize its surroundings, internal mechanisms kick in to restore equilibrium. Some researchers even speculate about quantum processes at the event horizon, where particles interacting in unexpected ways could act as a natural brake system. The implications rewrite our understanding of galactic ecosystems. If black holes can self-regulate, they're not just destructive forces, they're stabilizers, playing an active role in maintaining their galaxy's delicate balance. This could explain why some galaxies avoid the violent boom and bust cycles predicted by models. Their central black holes might be cosmic guardians, silently stepping in to prevent catastrophe. What's truly staggering is the scale of this self-control. The energy suppressed in this event could have powered a quasar for millennia, yet it vanished without a trace, absorbed by mechanisms we can't yet explain. It's a humbling reminder that for all their terrifying power, black holes might be far more nuanced and far more mysterious than we ever imagined. If they can defy their own explosive nature, what other cosmic rules might they be bending behind the curtain of the event horizon? This quiet rebellion against destruction doesn't just challenge astrophysics, it hints at a universe where even the most violent forces operate by hidden rules, where chaos and order dance in ways we're only beginning to glimpse. The next time you hear about a black hole's fearsome power, remember, sometimes the most astonishing thing isn't the explosion, it's the silence that follows. Cosmic voids are the universe's great emptiness, gaping chasms of nothingness stretching hundreds of millions of light years, where galaxies are few and far between. These regions aren't just empty, they're actively hungry, their gravitational pull slowly devouring surrounding matter like a cosmic vacuum. So when astronomers discovered a void so massive it dwarfed most known structures, they expected it to keep growing indefinitely, consuming everything in its path. But then, without warning, it stopped. Not gradually, not because it ran out of material to absorb, it just froze, as if hitting an invisible wall. The implications were staggering. Something out there had put the brakes on a force capable of rewriting the cosmic map. What could possibly halt a void's expansion? Gravity alone can't explain it. Voids grow because their emptiness creates a kind of negative pressure, pulling galaxies outward like a rubber sheet stretched too thin. For this void to stop, something had to counteract that pull, an unseen force pushing back. One theory points to dark energy, the mysterious substance accelerating the universe's expansion. Could dark energy act like a cosmic repellent, creating zones where voids can't grow? Picture blowing up a balloon with patches of thicker rubber. Those patches resist stretching, just as this void might have hit a region where dark energies push overpowered gravity's pull. But here's where it gets even stranger. Detailed scans revealed something unexpected at the void's edge. A faint, spiderweb-like network of dark matter filaments crisscrossing like a celestial net. These filaments shouldn't have been strong enough to stop the void's growth, yet there they were, acting like a barrier. Some researchers speculate this might be evidence of dark matter behaving in ways we've never seen, perhaps interacting with itself or other forces to form stable structures. Imagine a river meeting an invisible dam. The water doesn't know why it can't flow forward, but the barrier holds firm, the most mind-bending possibility. This void might have stumbled into a cosmic boundary, a region where the rules of physics shift slightly. We think of the universe as uniform, but what if it's patchwork with zones where gravity, dark energy, or even space-time itself operate differently? This void's sudden halt could be a clue that the universe isn't just expanding. It's structured with hidden frameworks governing where emptiness can and can't spread. This isn't just about one frozen void. It's about redefining how we see the cosmos. If voids can be contained, then the universe isn't a passive arena where chaos reigns. It's an intricate system with checks and balances, where even the hungriest emptiness has limits. And that raises a humbling question. If voids don't always consume, what else have we gotten wrong about the universe's grand design? This silent, stubborn void isn't just an anomaly. It's a whisper from the cosmos, hinting at orders and laws we're only beginning to sense. A Magnetar's fury is the stuff of cosmic nightmares, a stellar corpse so magnetically charged, its grip can atomize matter from thousands of miles away. When one of these monsters, lurking in a distant galaxy, suddenly unleashed a flare with the energy of 1,000,000 suns, astronomers braced for apocalypse. The blast should have been a galaxy-wide catastrophe, stripping atmospheres, shredding molecular bonds, and twisting the very fabric of space into knots. But when the light from the event finally reached Earth, the galaxy was fine, not just surviving, utterly unscathed, as if the Magnetar had never erupted at all. How does a galaxy shrug off a magnetic apocalypse? The leading theory is as baffling as the event itself. Instead of radiating outward in all directions, the flare might have been funneled, like lightning, channeled into a rod directed along an invisible magnetic highway stretching far beyond the galaxy. Picture a fire hose blast diverted into a drain pipe, its destructive force narrowly focused and harmlessly ejected into intergalactic space. But here's the catch. Magnetars don't just produce magnetic fields. They are magnetic fields, their entire existence bound to forces that should make such precision impossible. Yet something even stranger might be at play. Scans of the galaxy revealed traces of an enormous, previously undetected structure, a vast shell of ionized gas wrapped around it like a cocoon. This wasn't just random debris. It was layered, almost engineered, with properties that suggested it could absorb and dissipate magnetic energy. Think of it as a cosmic shock absorber, soaking up the Magnetar's fury and converting it into harmless ripples. The problem: nothing in known physics explains how such a structure could form naturally, let alone stabilize a blast of that magnitude. Some researchers wonder if this points to an undiscovered law of electromagnetism, one that allows certain galaxies to ground magnetic energy like a building diverting a lightning strike. Others speculate about dark matter's role, suggesting its particles might interact with magnetic fields in ways we've never observed, the wildest hypothesis. That magnetars themselves might have a built-in fail-safe, a self-regulating mechanism that prevents total annihilation. Imagine a volcano that only erupts sideways, sparing the villages at its feet. What's undeniable is that this event shatters our understanding of magnetic extremes. Magnetars were already the universe's ultimate oddballs, but now we're staring at proof that their deadliest tantrums can be neutered, not by chance, but by some hidden cosmic logic. If a galaxy can survive a Magnetar's worst, what other invisible safeguards might be woven into the universe's design? This isn't just a story of near destruction averted. It's a clue that even the cosmos's most violent forces play by rules we're only beginning to glimpse. And if a magnetic monster can be tamed, what else might be possible in this strange, orderly universe of ours? Galactic filaments are the universe's grand superhighways, delicate threads of galaxies and dark matter stretching hundreds of millions of light years, weaving the cosmos into a vast, interconnected web. These structures are so massive, their sheer scale defies human comprehension, yet they're also astonishingly fragile, held together by the faintest gravitational whispers. So when astronomers spotted one of these filaments stretched to its absolute limit, pulled taut between two colliding galaxy clusters like a cosmic tightrope, the outcome seemed inevitable. The math was clear. The gravitational forces at play should have shredded it instantly, scattering its galaxies into the void. But instead of snapping, the filament held firm, not just surviving but thriving, as if some unseen hand had reinforced it at the last possible moment. What could possibly keep a structure so vast, yet so fragile, from disintegrating under such unimaginable strain? The answer might lie in the dark matter woven through the filament like an invisible skeleton. Dark matter's gravity acts as cosmic glue, binding galaxies together across unfathomable distances. But in this case, researchers suspect something far more extraordinary. The dark matter might have realigned itself dynamically, redistributing its mass to reinforce the filament's weakest points. Picture a spider sensing vibrations in its web and swiftly spinning new silk where the strain is greatest. Only here, the silk is an enigmatic substance we can't even see, reacting with precision to forces that should have torn everything apart. Even stranger, the filament didn't just endure, it stabilized. Observations revealed that galaxies along its length weren't being pulled apart, but instead moved in eerily synchronized orbits, as if choreographed. This suggests the filament wasn't just a passive structure suffering external forces. It might possess a form of large-scale elasticity, a cosmic memory that allows it to absorb shocks and rebound. Think of it like a bridge flexing in high winds instead of cracking, except this bridge is 100 million light-years long, and the winds are the gravitational tides of colliding galaxy clusters. The implications ripple far beyond this single thread. If filaments can resist destruction so effectively, entire models of cosmic structure formation might need revisiting. We used to think of them as transient features destined to dissolve as the universe expands. But this one's resilience hints at a hidden order, a self-correcting mechanism woven into the fabric of the cosmos itself. Could dark matter learn to adapt? Could the universe's largest structures have built-in defenses against their own dissolution? What's truly humbling is how much this event reveals about what we don't know. For decades, we've mapped the cosmic web assuming it follows predictable mechanical rules. But this filament's defiance suggests there's more at play: subtle, dynamic interactions between dark matter, gravity, and the invisible scaffolding of space-time that we're only beginning to sense. The next time you look up at the night sky, remember, even the emptiest stretches of darkness might be threaded with unseen resilience, holding the universe together in ways we're just starting to imagine. And if a single filament can rewrite the rules of cosmic fragility, what other secrets might the great cosmic web be hiding? Star clusters are cosmic families, tightly bound groups of stars orbiting one another in perfect harmony, their gravity stitching them together like an intricate dance. But when one of these clusters strayed too close to a supermassive black hole, astronomers expected a massacre. The tidal forces should have ripped stars from their orbits, flinging some into the void while others spiraled into oblivion. Yet against all odds, the cluster emerged unscathed, its structure untouched, as if the black hole's gravity had simply skipped over it. How does a star cluster walk through a gravitational shredder and come out intact? The answer might lie in something far stranger than sheer luck. Observations revealed the cluster wasn't just dense, it moved with eerie synchrony, its stars orbiting in near-perfect alignment. This synchronized motion could have created a collective gravitational shield, a kind of group armor that deflected the black hole's disruptive pull. Picture a school of fish darting in unison to evade a predator. Their coordinated movement makes them harder to target. In this case, the stars' shared rhythm might have cancelled out the black hole's tidal forces, rendering them harmless. But here's the twist: this explanation only scratches the surface. Detailed simulations show that even synchronized orbits shouldn't fully protect a cluster from a black hole's grasp. Something else was at play, perhaps an unseen layer of dark matter woven through the cluster like an invisible net, absorbing the gravitational shockwaves. Or maybe the cluster's very shape played a role. Most star clusters are spherical, but this one showed hints of an elongated structure, like a cosmic spear piercing through the black hole's influence. If true, its unusual geometry could have allowed it to slip through the danger zone like a needle threading a storm. The implications are profound. If star clusters can armor themselves against black holes, entire models of galactic dynamics might need revision. We've long assumed these clusters are fragile, destined to dissolve when faced with cosmic giants. but this one's defiance suggests they're far more resilient than we thought, maybe even capable of engineering their own survival. Could synchronized orbits be a universal survival tactic? Do other clusters harbor similar hidden defenses? What's truly staggering is the precision required for such a feat. The star's movements would need to be flawlessly coordinated, their gravitational bonds fine-tuned to resist disruption. It's almost as if the cluster knew the black hole was coming, a level of cosmic foresight that borders on the miraculous. This event doesn't just challenge our understanding of star clusters, it hints at a universe where order emerges from chaos, where even the smallest structures can outwit the mightiest forces. And if a humble star cluster can cheat destruction so elegantly, what other cosmic underdogs might be hiding similar tricks up their sleeves? The cosmic web is the universe's ultimate architectural marvel, a sprawling network of galaxies and dark matter filaments stretching across billions of light years, connecting everything in a delicate, thread-like embrace. These filaments are so vast, they make entire galaxy clusters look like mere beads on a string, yet they're also astonishingly fragile, held together by the faintest gravitational tugs. So when astronomers witnessed two of these colossal strands collide head-on, the outcome seemed inevitable. The forces at play should have shattered both structures, sending galaxies careening into the void like scattered marbles. But instead of chaos, something extraordinary happened. The filaments didn't break, they didn't even bend. They passed through each other like ghosts, their galaxies undisturbed, their structures perfectly intact. It was as if the universe had threaded them with unbreakable cosmic silk. What could possibly hold something so enormous and so fragile together against such titanic forces? The answer might lie in the invisible scaffolding of dark matter woven through the filaments. Normally, dark matter acts like cosmic glue, its gravity binding galaxies together. But in this case, researchers suspect it did something far more sophisticated. Scans revealed the dark matter in these filaments wasn't just passively holding things together. It was actively redistributing itself during the collision, reinforcing weak points in real time. Picture a bridge sensing an earthquake and instantly shifting its weight to compensate, except this bridge is 100 million light-years long, and the earthquake is a collision with another universe-spanning structure. Even more baffling is how the galaxies within these filaments behaved. Instead of being flung into chaos, they moved with eerie coordination, as if guided by some unseen choreographer. This suggests the cosmic web isn't just a static map of the universe. It might be a dynamic, almost living system, capable of self-correction. Some theorists even speculate that dark matter filaments could possess a form of elasticity, a cosmic memory that allows them to absorb impacts and snap back into place. Think of it like a spider's web trembling under the weight of a raindrop, only to rebound perfectly once the droplet passes through. But here's the real mystery: this level of coordination shouldn't be possible. The distances involved are so vast, the timescale so immense, that any stabilizing mechanism would need to operate faster than physics should allow. Unless dark matter isn't just matter, what if it's something far stranger, a substance that doesn't just respond to gravity but anticipates it? Some models suggest dark matter particles might interact in ways we've never detected, creating feedback loops that stabilize structures before they can fray. It's like the universe has built-in shock absorbers, tuned to perfection over billions of years. The implications rewrite our understanding of cosmic evolution. If filaments can survive collisions unscathed, the cosmic web might be far more resilient than we ever imagined. Galaxies aren't just floating in isolation. They're cradled in a network that actively protects them, a safety net woven from the fabric of space itself. And that raises an even bigger question. If the universe's largest structures are this durable, What else have we underestimated about its hidden architecture? This event isn't just a curiosity, it's a glimpse into a cosmos where even emptiness has order, where chaos is quietly kept in check by forces we're only beginning to sense. The next time you look up at the night sky, remember, those dark stretches between the stars might be hiding the universe's best-kept secrets. Pulsars are nature's most precise timekeepers, cosmic lighthouses born from the ashes of supernova, their beams of radiation sweeping across the universe with metronomic regularity. As they spin, they lose energy, slowing down bit by bit over millennia, their rhythm gradually fading like a wind-up toy running out of steam. That's how it's supposed to work anyway. But deep in the heart of a distant galaxy, astronomers found a pulsar that broke all the rules. This one wasn't slowing down, it wasn't even stuttering. It spun at nearly the speed of light, its rhythm unchanging, as if some invisible hand kept rewinding its cosmic clock. The numbers didn't add up. At that speed, the pulsar should have bled energy catastrophically, its rotation decaying into chaos or collapsing entirely into a black hole. Yet there it was, defying physics with every flawless pulse. Some hidden engine was at work, counteracting the energy loss, but what? One leading theory points to quantum vortices deep within the neutron star's core. Picture a superfluid ocean of subatomic particles swirling beneath the surface, generating currents so powerful they transfer energy back into the pulsar's spin like a cosmic dynamo. It's as if the star has a hidden battery recharging itself faster than it can drain. But here's where it gets even stranger. This pulsar's timing isn't just steady, it's perfect. Most pulsars wobble slightly as they spin, their beams flickering like a candle in the wind. This one's pulses hit like a Swiss watch, with no deviation across centuries of observation. That kind of precision shouldn't be possible without some form of active stabilization, almost as if the pulsar is correcting itself. Could neutron stars possess internal mechanisms we've never imagined? Some researchers speculate about exotic phases of matter in their cores, crystalline structures or quantum condensates that act like gyroscopes, keeping the spin flawlessly balanced. The implications rewrite our understanding of stellar corpses. If pulsars can tap into hidden energy reserves, they might be far more than lifeless cinders. They could be cosmic power plants, their interiors humming with processes we've yet to uncover. And if one pulsar can cheat entropy so spectacularly, how many others might be doing the same, quietly defying the universe's slow march toward decay? This isn't just a curiosity, it's a clue that even in death, stars hold secrets that could redefine the boundaries of physics. The next time you hear the steady tick of a pulsar's beam, remember, some of them might be playing by rules we haven't even discovered yet. Dark matter hurricanes should be the ultimate cosmic wrecking balls, invisible tempests of high-speed particles capable of shredding galaxies apart from the inside out. When astronomers detected one of these storms barreling toward a spiral galaxy, the outcome seemed inevitable. The dark matter particles, moving at a significant fraction of light speed, should have torn through the galaxy's delicate structure like bullets through tissue paper, scattering stars and warping orbits into chaos. Yet when the storm passed, the galaxy stood untouched, its spiral arms pristine, its stars undisturbed. It was as if the hurricane had simply parted around it, leaving no trace of its fury. How does a galaxy weather a storm of invisible, intangible particles? The answer might lie in something even more mysterious than dark matter itself. Observations revealed the galaxy was enveloped in a vast, diffuse halo of its own dark matter, a kind of cosmic buffer zone that absorbed the incoming particles without transferring their destructive energy to the visible stars. Think of it like a ship sailing through a hurricane, but with an invisible force field that converts the raging winds into harmless ripples. The galaxy's dark matter didn't just shield it, it acted like a sponge, soaking up the storm's momentum and dissipating it silently into the void. But here's the puzzle: dark matter isn't supposed to interact with itself. By definition, it's dark because it doesn't collide or scatter like normal matter. It passes through everything, including other dark matter. So how could this galaxy's halo absorb the impact? Some theorists speculate that dark matter might not be as simple as we thought. Perhaps there are multiple flavors of dark matter, some of which can interact, creating friction or pressure that deflects incoming particles. Imagine two crowds passing through each other in the dark. Most walk right through, but a few shoulders bump, subtly altering the flow. The implications are staggering. If galaxies can armor themselves against dark matter storms, entire models of cosmic evolution might need revisiting. We've long assumed dark matter is a passive backdrop, a gravitational scaffold holding galaxies together. But this event suggests it could be dynamic, even reactive, a hidden defense system woven into the fabric of the universe. And if one galaxy can repel a dark matter hurricane, how many others might be doing the same without us noticing? What's truly humbling is how little we understand about the forces at play. For decades, dark matter has been the universe's greatest unsolved mystery. Now we're staring at proof that it might be far more complex and far more alive than we ever imagined. This galaxy didn't just survive a storm. It revealed a cosmos where even the invisible, the intangible, obeys rules we've yet to uncover. And if dark matter can shield galaxies from its own fury, what other cosmic safeguards might be hiding in plain sight, waiting for us to look closer? Cosmic strings are the universe's most elusive ghosts, theoretical cracks in space-time so thin, they're narrower than an atom, yet so dense, a single inch would outweigh a mountain. According to physics, these relics from the Big Bang should vanish almost instantly, unraveling in a flash of energy as space-time smooths itself out. But when astronomers spotted one lingering in the depths of intergalactic space, untouched by time, it wasn't just a curiosity, it was a revolution. This cosmic string didn't decay. It didn't even flicker. It hung in the void like a frozen lightning bolt, defying every prediction about how the universe should behave. What could keep a flaw in space-time from healing itself? The answer might rewrite our understanding of reality itself. Normally, cosmic strings are thought to be unstable, their immense tension causing them to snap apart in bursts of gravitational waves. But this one seemed to exist in a state of perfect balance, as if the forces that should have torn it apart had been mysteriously neutralized. Some theorists suggest it might be wrapped in a sheath of exotic matter. Particles unlike anything we've seen, whose properties could act like cosmic duct tape, holding the string together against all odds. Picture a crack in ice that refuses to spread because something invisible is sealing its edges. Even stranger, the string wasn't just persisting, it was thriving. Scans revealed faint gravitational ripples emanating from it, a hum of energy that suggested it wasn't a dead relic but an active structure, humming with processes we don't yet understand. This wasn't just a frozen scar in space-time. It might be a living one, vibrating in ways that defy conventional physics. Some models even propose that cosmic strings could be threaded with quantum filaments, tiny strands of energy that stabilize them like the reinforcing rods in concrete. The implications are staggering. If cosmic strings can linger indefinitely, they might be far more than theoretical oddities. They could be the universe's hidden architects. Some researchers speculate these strings might weave through the cosmos like invisible wires, shaping the paths of galaxies and bending the flow of dark matter. Others wonder if they could be time capsules, preserving information from the universe's first moments in their twisted geometry. And if one string can defy decay, how many others might be out there, silently shaping the cosmos in ways we've yet to detect? This isn't just about a stubborn crack in space-time. It's a clue that the universe might be threaded with structures we've only begun to imagine, flaws that aren't flaws at all but features of a deeper, more intricate design. The next time you look up at the night sky, remember, the emptiness between the stars might be crisscrossed with invisible threads, holding the cosmos together in ways we're only starting to glimpse. And if a cosmic string can outlast time itself, what other secrets might be woven into the fabric of reality? White dwarfs are the universe's time bombs, stellar embers so dense, a teaspoon of their matter would weigh as much as an elephant. They're supposed to be the quiet end game of stars like our sun, cooling slowly over billions of years. But when one particular white dwarf in a distant galaxy ballooned past the Chandrasekhar limit, the critical threshold where these dying stars should detonate in a supernova, astronomers held their breath. At 1.4 times the mass of our sun, this cosmic relic had crossed the point of no return. The equations were clear. It should have torn itself apart in a cataclysm bright enough to outshine its entire galaxy. Yet as scientists watched, the white dwarf did nothing. No explosion, no collapse, just eerie, impossible stability. This wasn't just a delayed reaction. It was a full-blown defiance of astrophysics. The Chandrasekhar limit isn't some rough guideline. It's as fundamental to stellar evolution as the speed of light is to relativity. Exceed that mass, and the white dwarf's gravity should overwhelm the quantum forces keeping it stable, triggering runaway fusion that obliterates the star in seconds. But this one didn't just skirt the limit. It smashed through it and kept on ticking, like a clock that keeps perfect time even after its springs have snapped. So what could possibly rewrite the rules of stellar death? One leading theory points to rapid rotation. Imagine a white dwarf spinning so fast, its centrifugal force counteracts gravity like a cosmic merry-go-round. This might buy the star extra time, redistributing mass outward like a spinning ice skater extending their arms. But here's the catch. Even the fastest spin shouldn't stabilize a white dwarf this massive indefinitely. The numbers don't add up unless there's another factor at play. That's where things get truly bizarre. Spectroscopic analysis revealed traces of exotic elements coating the white dwarf's surface metals that shouldn't exist in such concentrations. Some researchers speculate these elements might be acting like a stellar pressure cooker, forming a crystalline lattice in the star's outer layers that reinforces its structure. Picture a dam reinforced with unbreakable alloy, holding back floodwaters that should have burst through long ago. Others wonder if magnetic fields trillions of times stronger than Earth's could be pinning the star together, creating an invisible cage that prevents collapse. But the most radical possibility, this white dwarf might be feeding. Observations show it's orbited by a smaller companion star, and traces of stolen matter spiral toward it like water down a drain. Normally, this would hasten a supernova. More mass means more gravity means more instability. Yet somehow, this white dwarf seems to be digesting the material in a way that maintains equilibrium, like a fire that burns hotter without exploding. It's almost as if the star has developed a cosmic metabolism, regulating its intake to avoid catastrophe. The implications shake astronomy to its core. If white dwarfs can bypass the Chandrasekhar limit, entire chapters of astrophysics textbooks need rewriting. Supernovas aren't just fireworks, they're cosmic recyclers, scattering heavy elements that form planets and life. If some white dwarfs skip this step, whole regions of the universe might be missing their share of these building blocks. Even more unsettling, If this star's stability isn't a fluke but a feature, how many other white dwarfs might be hiding similar tricks? What's truly humbling is how this star exposes the gaps in our knowledge. For nearly a century, the Chandrasekhar limit stood as an unshakable pillar of stellar physics. Now we're staring at proof that the universe has loopholes we never imagined, places where the rules bend, where stars rewrite their own destinies. This white dwarf isn't just a curiosity, it's a cosmic rebel, challenging us to rethink what we know about life, death, and the delicate balance that governs the stars. And if one dying sun can cheat oblivion so spectacularly, what other cosmic rules might be waiting to be broken? Galactic winds are the universe's ultimate pressure washers, rivers of charged particles roaring from star-forming regions at millions of miles per hour, fierce enough to scour entire galaxies clean of gas and dust. When astronomers detected one of these winds in a distant spiral galaxy, its power was off the charts, enough energy to hurl stars straight out of their orbits and into the void. Yet when the cosmic gale subsided, something impossible came into focus. Every star remained perfectly in place, as if the wind had parted around them like a river flowing around unshakable stones. The numbers made no sense. At those velocities, even massive stars should have been uprooted, their gravitational bonds to the galaxy shattered by the wind's relentless push. Instead, the stellar population stood untouched, while the surrounding gas and dust bore the full brunt of the storm. This wasn't just a near miss, it was a cosmic magic trick, one that hinted at forces acting on stars in ways we've never observed. The leading theory, an invisible scaffold of magnetic fields woven through the galaxy like a spiderweb, might have anchored the stars in place. Picture a tree's roots gripping the soil during a hurricane, except here, the roots are made of pure magnetism, and the hurricane is a tempest of particles streaming across light years. But magnetism alone might not explain the precision of this shielding. Scans revealed something even stranger. The stars weren't just resisting the wind, they were redirecting it. The wind's path curved around stellar neighborhoods in unnatural arcs, as if repelled by some unseen barrier. Some researchers speculate that stars themselves might generate localized gravitational eddies, creating pockets of calm in the particle storm. Think of it like rocks in a rushing stream where the water swirls around them but leaves their surfaces dry. If true, it would mean stars aren't just passive victims of galactic weather, they're active participants shaping their own survival. The implications ripple far beyond this one galaxy. If stars can collectively deflect something as powerful as a galactic wind, entire models of galactic evolution might need revisiting. We've long assumed these winds are destructive forces, stripping galaxies bare over time. But what if they're more like cosmic pruning shears, selectively sculpting galaxies while leaving their stellar hearts intact? This event doesn't just challenge astrophysics, it suggests galaxies might be far more resilient, far more organized than we ever imagined. What's truly astonishing is the scale of this coordination. For stars to resist such a wind, their protective mechanisms would need to operate across vast distances with a synchronicity that defies random chance. It's almost as if the galaxy itself has a built-in immune system, one that senses incoming threats and deploys defenses we can't yet measure. The next time you gaze at a spiral galaxy's delicate arms, remember, those stars might be huddled under invisible umbrellas, weathering storms that should have blown them into the abyss. And if one galaxy can cheat the cosmic winds so flawlessly, how many others might be hiding similar secrets in plain sight? The universe had one last card to play, a cosmic bullet so vast, so powerful, it could have rewritten the map of the heavens. Astronomers watched in stunned silence as a shockwave from an ancient, unfathomable event, perhaps the collision of entire galaxy clusters, rippled through intergalactic space, heading straight for a delicate web of galaxies. The math was apocalyptic. At that speed, that scale, the wave should have shattered galactic filaments like glass, sending stars adrift into the void. Yet when it arrived, something impossible happened. The wave didn't destroy, it didn't even disrupt. It passed through the galaxies like a ghost, leaving no trace of its passage. It was the universe's greatest near miss, a cataclysm that never was. What could bend the rules of destruction so completely? The leading theory hinges on dark energy, the mysterious force accelerating the universe's expansion. Some suggest this wave wasn't a traditional shockwave at all, but a ripple in the fabric of space-time itself, a fluctuation in dark energy's influence. Picture an ocean wave passing through a net. The net trembles but doesn't break. In this case, the net might be the invisible scaffolding of dark matter and dark energy that undergirds the cosmos, absorbing the shock before it could reach the galaxies we see. But here's the twist: this wave didn't just fade. Observations revealed it split, forking around galaxy clusters like water, diverting around stones in a stream. That level of precision suggests something even stranger. An active, almost reactive universe where cosmic structures don't just endure chaos but adapt to it. Some researchers speculate that dark matter halos might act like shock absorbers, redistributing energy in real time to protect the galaxies within. Others wonder if the wave's energy was siphoned away by quantum fluctuations, vanishing into the vacuum of space before it could do harm. The implications are humbling. If the universe can neutralize threats of this magnitude, how many other cosmic bullets has it dodged without us noticing? We've long assumed galaxies are fragile, at the mercy of the cosmos's violence. But this event paints a different picture, a universe that's not just chaotic but resilient, with hidden safeguards woven into its very fabric. It's as if the cosmos has an immune system, silently deflecting existential threats we've only begun to detect. This isn't just a story about a near miss. It's a revelation that the universe might be far harder to destroy than we ever imagined. For all its cataclysms and collisions, there are forces dark, subtle, and profoundly mysterious working to preserve the delicate balance of everything we see. And that leaves us with one final, breathtaking question. If the universe can survive its own worst, what else might it be capable of? The answer, it seems, is still written in the stars, waiting for us to look closer. From rogue black holes to vanishing quasars, these 20 cosmic events aren't just scientific curiosities, they're cosmic wake-up calls, forcing us to admit how much we still don't understand about the universe. Each anomaly is like a puzzle piece from a box we didn't know we were missing, revealing gaps in our knowledge where entire new laws of physics might be hiding. Take that mysteriously silenced quasar. How does a trillion-sun powerhouse just switch off without consequences? Or the neutron-star merger that happened in perfect silence, defying every prediction about how these collisions should behave. These aren't just oddities, they're proof that the cosmos operates with a hidden rulebook we've only glimpsed. What's truly humbling is how these events expose the limits of human knowledge. For centuries, we've mapped the heavens with equations and models, confident we understood the basic rules, but these cosmic survivors laugh at our textbooks. That galaxy surviving a gamma-ray burst, it shouldn't exist. The white dwarf that smashed through its death threshold without exploding, that rewrites stellar physics. Even dark matter, the invisible glue holding galaxies together, is now showing abilities we never predicted, from forming protective barriers to redirecting hypervelocity stars. Every time we think we've got the universe figured out, it throws us another curveball. Yet these mysteries aren't roadblocks, they're invitations. Each unexplained event is a flashing signpost pointing toward discoveries we haven't even dreamed of yet. Maybe dark matter interacts in ways we can't detect. Maybe there are hidden dimensions influencing gravity, or perhaps the universe has self-correcting mechanisms we're only beginning to sense, like some cosmic immune system protecting against its own worst extremes. Whatever the answers, one thing's certain: the cosmos is far stranger, far more inventive, and far more resilient than our boldest theories predicted. So what does this mean for the future of space exploration? It means every telescope, every satellite, every equation-scrawled chalkboard is part of a grand detective story, one where the universe keeps changing the rules mid-game. The James Webb Space Telescope might spot a galaxy that laughs at dark matter. A gravitational wave detector could catch a black hole doing something flat-out impossible. And with each new discovery, our maps of reality will keep expanding into territories we can't yet imagine. That's the real beauty of these cosmic survivors. They're not just defying destruction, they're revealing a universe that's richer, weirder, and more wondrous than we ever dared to hope. So the next time you look up at the night sky, remember, out there in the darkness, the impossible is happening every day. And who knows, the next great cosmic revelation might be hiding in plain sight, waiting for someone, maybe even you, to connect the dots. What cosmic mystery fascinates you most? Drop your thoughts below, and if you're hungry for more universe-shaking discoveries, hit that subscribe button because the cosmos is just getting started.